delay today. It was hectic a little bit, but finally I got into the virtual class. So welcome all, and we are going to continue on our chapter TCP/IP. So you know TCP/IP is the most famous protocol stack or protocol suite used. We discussed actually what is TCP/IP, the considerations, why it is important, its advantages, and the two important parts of it, the TCP, which is as a protocol, and the IP as a protocol. We said there are the two major protocols in the TCP/IP stack, and actually the IP is used for routing, the TCP is used for end-to-end communication, which has connection-oriented ability, and the IP is a connectionless protocol. Now let's move on and talk about the address translation. So we have seen the meaning of NAT. So NAT means network address translation, and it's the process in which the address of your devices is translated to another address when it goes outside to the internet traffic. So here you can see a figure which I have local client and I have the internet. So the local client is actually a part of the network. So inside the network, it has a private address. It's 192.168.1.127. This is a private address within the network only. So this packet, when it goes to the internet, it should pass by the proxy server or by the router. So the router will give it another IP address. It will translate this address to this one, which is the address of the network, which is provided by the ISP. So all the addresses in the internet are actually provided by the ISP only. But within the network, inside it, the addressing could be done by DHCP or could be done manually. Okay, so now we know what's the meaning of NAT. NAT is the translation of the address from inside network to the outside of the network in the internet, and the vice versa. When the packets come back from internet to a certain device inside the network. And you can try this. For example, you can have a ad hoc Wi-Fi network between your mobile, your home router, and your laptop, for example. Let them be all in the same network. You will notice that all the traffic coming either from your mobile or from your PC, all the packets, they have the same IP, which is the IP of the access point. It will have the same IP, but actually within the network, there are different IPs. So talking generally, there are many classes. If we want to talk about IPs, they are divided into formally three classes are working, which are A, B, C. D and E are not used. One is for multicast. The E is reserved for experimental purposes. So we should know each class well, because we might be asked about, given an IP address, which class does it belong to? Okay, so for class A, it's designed for very large networks. Designed for very large networks because the first octet value of 126 or less, a first octet value of exactly 127 in the case of software loopback test address. So this class is designed for a very large network only, and it's the first octet. Actually, we mean by octet that the address is like that. Here is a number, 4 numbers separated by dot. It's called dot decimal notation. Okay, so when we say the first octet, we mean this one, the first one, because this is octet. Octet means a number in the octal system. We are using, as a human, we are using the decimal system, but there is the octet. So it's called octet because it's a byte. It has only 8 bits. So this number will never exceed 255. It will never exceed the number 255. From 0 to 255, all of them. Okay, so let's look at the classes. This is the class A. Class B designed for medium-sized network. First octet value will go from 128 to 191. Okay, class C designed for smaller networks, and the first octet is value of 192 through 223, and these are actually the functional classes. These classes are widely used. These are used only, but these, the D and E, D is for multicast. Okay, what we mean by multicast is that whenever you find an address in this range, it means that it does multicast. The message is sent to many computers. Okay, not only one. It's a multicast is similar to broadcast, but broadcast is the spread of information to all devices, but multicast is for certain group. So it cannot be used for network. These are for multicast only, and they start from octet 224 through 239. E cannot be used at all, either for multicast or for a network, because reserved for experimental purpose. And they are all the octets more than 239. So how you can remember this? You have just know, you just need to remember that when the first octet is less than 126, from 0 to 100, the first octet, this one, then it's class A. Anything after 127, less than 191, is class B. Class A starts from 192, and D from 224, and anything greater than 239 is considered E. Okay, so here you can see what does that mean. The classes actually defines the bits used for network and the bits used for the host. So why did we say class A is the largest, is suitable for the very large network? Why did we say that? Because you can see the host, the space available for host address. The IP address actually is divided into, or can be divided into 2 addresses, the host address and the network address. So in this address provided something called subnet, or there is another naming also. We can get the network address and the host address. So in this address, if you have 8 bits at the beginning, 24, the others are for host, it's class A. Okay, because all these are 32 bits. 32 bits, divide 32 over 4, it becomes 8. So that's we call each one octet, 1 byte, 8 bits. So this is the organization. Class B, you can see that we have given the more space to the network address. Class C, many networks, less hosts. Okay, so you see in the first one you can have a lot of hosts, A lot of hosts can be here. Class B, less for medium network. Class C for small networks, because you have 8 bits. And if you want to know how many devices can you have in 8 bits, you just calculate 2 to the power 8 and see what is the host available. Yeah, it has only 256 hosts only. Okay, this is for class C. So that's why they say it's for small networks. So this is the organizations now of class A, B, C, D. Of course, as I said, D and E are not practically used. You have to know them only now, but you are not going to face them because they are, E is not used at all. D is used, but for multicast, which is available only in very large networks. Okay, and this one is the loop back. Whenever you see an address starts by 127, it's actually loop back. What do we mean by loop back? It's an address given to test the network or to test the IB, TCP IP within your device without a network. Okay. Sometimes, for example, I'm building a server. Say I'm building a server, and I would like to test that server. So you can try the loopback to avoid the hassle of hosting the website externally, trying it. This will take a lot of time and take a lot of resources also, because you will use the network, you will use many things together. Okay, so we go to subnetting. Subnetting, yeah, it's used for testing the network, the TCP IP within the device itself, within the device. Okay, no buckets were going to be transmitted. Actually, for simulation, if you want to simulate sending to your machine. So it's similar to when you send to this IP, the message will come back to your device, similar to sending to yourself. So subnetting is term used to divide the network address into smaller networks. Now we have the classes. We can either use these classes as a default subnetting, or you can have your own subnetting. So it also divides 32-bit address, which is the IB4, creates a large number of new network addresses. Its advantage, it minimizes network travels, because you will have logically separated networks. It will isolate networks from one another. It improves performance, of course. Defines limit of broadcast domain. It optimizes use of IP address space, and it enhances the ability to secure a network. Okay, so subnetting means dividing the network into many networks and deal with them after that. So there is something called the IB subnet, which is the subnet actually uses host address bits as additional network bits, creating additional networks. Can be routed independently, allowing much better use of address space and bandwidth. So let's go to the subnet mask. Subnet mask is actually a number or a pattern of consecutive ones followed by zeros. If they are logically AND with the IP address, then they indicate which bits that identify the host from the network. Okay, so the network address will be the ones, and zeros are the host. Okay, so the subnet mask, for example, you can say this is a subnet mask. 255.5.0.0. Okay. So what does this mean in binary? In binary, it means these are ones. These are ones. And ones here. 8 ones, actually. 8 zeros here. 8 zeros here. When you logically AND it, make AND operation, then it will give you actually the part of the network. Sometimes you need to know the network address. It's important when you have an IP address, you should know the network address. Should know the network, which is the network address, which is the host address. So 0 zeros for host number, yes. The final result will be the network address. So Subnet Mask is actually used only to identify what is the network address. Given an IP address, what is the network address? Okay. So you see here, this is the Subnet Mask we have, and this is the IP address of this network. This is another network, you see. So this is Subnet Mask, the IP address. Subnet Mask, the IP address. So using the subnets, you can have the Classful Network, which is the network subnetted to default boundary of network host bit based on a class of IP address. If your address, your network is divided according to a class, like class A, B, C, then it's called Classful Network. Otherwise, it is not classful. Okay? There is something called the variable length subnet mask, which is subnetting option. Use more appropriate varied subnet mask with same classful network for different subnet sizes. A subnet is known and understood only locally. So router use subnet mask to compare computed network address with the routing table entry corresponding to mask used. Okay, so the subnet is only known local, so the routers, they have tables, so they can make the NAT, network address translation, to retain the address to the private address again inside. So these are the subnet mask buttons for the classes. For class A, you see, this is the subnet mask. For class B, this is a subnet mask. And for class C, this is a subnet mask. Okay? So you see here that the number is becoming larger every time because of these ones, the number of networks available. So here the number of network is very less, but the number of hosts is a lot, you see, the many zeros. And then it becomes smaller. Yeah, C has limited hosts. Uh, 255. No, there is. This is not possible. Okay, 255, 255. Yeah, this is not possible actually, because it in this way you have network address only. Where is the host address? Okay, you have to define. You can have. Let me tell you something. You can have this. You have posted a good question. You can have something like 5-4. This is acceptable. You see, we have only one bit for the host. So a host can take only from 0 to 1 bit. Okay? Yeah. So let's move. Here, this is important also. The classless interdomain routing. which is another name representing for representing the network without having to write subnet mask. Okay, it's another representation. So it's an alternative representing IP or subnet mask. It is by the slash. You type the network address followed by a slash. The number after the slash will give you the number of the bits in the IP address range used as the network address. Okay, so the number after the slash, if you will use this notation CIDR, you will consider this number as gives you how many bits you will use as the network address, and it will be clear. So now for class A, X will be what? For class A, yeah, 24 is class C subnet, yes. So for class A it will be 8, right? Because for class A the network is less, only 8 bits for network, but the many hosts, they are very big number for hosts. This is for class A. For class B it will be what? 16. Okay, 16, because you add 8. The rule is that you add 8 every time. Okay, so in A it's 8, in B 16, C is 24. Okay, so D is 32. But you can also have a subnet mask like this. It's not actually required to be in the classes. If your network is in one of the class A, B, C, then it's classful network. Otherwise, it could be a network like this. Okay, it has only 21 bits for the network address. Yeah, in this case, you can also calculate it by hand, no problem. Okay, only a calculator or by hand, because this number make it into binary, and then when you make it into binary you can manipulate with the bits. Here we will see examples now. See this here, this is the CIDR, the classless interdomain routing. You see, this is class A, this is not a class, this is class B, and we go, this is class C. Okay, so this is our examples of the two ways. We can identify the network by the subnet mask, or we can identify it by writing it in the CIDR. Okay, see here, this is an example of a classful network of class C that was divided into 4 subnets. So you see that this is the first network, which starts from 0 to, from 1, the address, until 63. So 64 is the network 2, starting with the first node 65 until 127. You see how we can divide into subnets? It's simple, especially when you are dealing with the classful network. But if the network is not classful, then you need some calculations. Okay, is this clear? You see, we start, because this is class C, we have to start from this, only the last octet, because actually the subnet mask is 255.255.255.0. Okay, so the hosts lie in this 0, last octet. So that's why, and we want to divide it to four networks. We want to divide the network of class C to 4 networks. So what we do actually, we start from 0 here, let it be the first network. Okay, and then we go give the addresses from 1 to 63. Then give the address from 65, 1, 27, and that's it until you reach the end. Okay, so here is a mistake. Make this into your presentation slides. This should be, there is no 2 here. Okay, correct this in your slides if it is the same. It's 192. Okay, so yeah, we go to move. This is an example. You can see symbol address used. So here in this chapter, you are actually not required to do the subnetting in not classful network or in a big network. Actually, what you're required to do is that you should know which kind of IB is a class A, which kind of IB is a class B, which kind of IB is a private IB. Okay, that's it only. You are not required to build a network. Okay, so we are about to finish. These are the private addresses. So whenever you find this range, it means that the address is private. In another word, it means that the address cannot be dealt with in the internet. It is for the use only inside your network. So addresses from 10, you see these ones. So this belongs to class A, class B, class C. Okay, so these can be used for network, but they will not work in the internet. So you will never see an IP address of this in the internet space. There are also sockets and boards. So sockets associate actually the board address with the IP, and you can use them in order to create server client applications to communicate with each other. These are the well-known board numbers we have, so just pay attention to the famous ones such as the SMTP, POP3, HTTP. Okay, these are boards, and then you see all of them are using the UDP and TCP. So there are some information about the DNS, which is the domain name system. I will leave it to you to study. Actually, the rest of chapter is only talking about resolving the hosts and the naming of hosts. There are host files. There are the DNS, which is system to give the names. It has records. It's like a database, okay, in a tree like to organize the names in the internet, such as .com, .edu, .sa, whatever. Okay, so you can have a look at this, and there are also settings like this. These are not very important because these are practical things. But if you want to apply the IP addressing on your machine and this, you can have a look at them. And finally, this chapter ends with some commands. Okay, so go through these commands. I think most of you know ipconfig, right? So ipconfig shows you the IP address, subnet mask, all the information about your NIC. Even it shows you the MAC address if you want. Okay, so in investigate this command: ping, path ping, trace RT. So all of them are network troubleshooting commands. You can have a look at them. Okay, I wish if we had more time. I wanted to solve some review questions with you and discuss, but it's okay. This chapter seems very easy. Just go through it. It's a little bit more rich with information, but at the end, it's only about what is TCP and IP, how addressing is done, in addition to the DNS, and finally some commands which you might already know. Okay, so this is our last section for this chapter. Before you leave, I need to record your attendance. So yeah. So that's it for today. Please go through the chapters you already had on this chapter also, because there are no many lectures left for the final exam. Final exam is approaching, so it's better not to forget the old information you have, because it's all interlinked, especially in the networks like programming. IP address is IP address. Wherever you go to next chapter, or if you ever change the book, it will be the same. So thank you and goodbye. Have a good week, and see you inshallah next week.
Recording stopped.